Welcome, my dear friends, to my new YouTube channel. Today, we will discuss the use of IC 7495 as a shift register. So, this is the pin diagram of IC 7495, or you can say 5495. Here you can see that A, B, C and D are the input terminals and QA, QB, QC, QD are the output terminals. The pin number 1 is a serial input terminal, means this IC can be used in parallel out mode as well as serial in parallel out mode. Here pin number 6 is mode control pin, which controls the mode of IC as parallel input or serial input. We can apply the clock pulses at pin number 9 or 8 called clock 1 or clock 2. You can see that these are active low, means during the transition of clock pulse from plus to minus, the clock pulses will be applied to these pins. VCC is applied to pin number 14 and pin number 7 is connected to ground. Now, if we connect the mode control pin 6 to logic 1 by applying high voltage, then the output of this NOT gate is 0 and the output of this inverter is 1. So what happens that as this terminal is high, so this AND gate becomes active and this AND gate becomes inactive due to 0 voltage. Further, as this 0 voltage is applied to these 4 AND gates, so these gates become inactive, whereas this high voltage is applied to one of the input pins of these AND gates, so the parallel input pins are active, means we can apply parallel input voltage at pins A, B, C and D. And as soon as we apply the clock pulse, whatever is the input applied at A, B, C and D, it will appear at QA, QB, QC and QD. For example, if we apply 1010 at the input A, B, C and D, then as soon as the clock pulse appears here, the outputs will also become 1010. So this way, whenever mode control is connected to 1, at that time clock 2 is active and the IC works in, parallel out mode. Now, when we connect the mode control pin 6 to logic 0 by applying low voltage, then the output of this NOT gate becomes high and the output of this inverter becomes 0. Now, as the mode control is at low voltage, due to that, this AND gate becomes inactive and we cannot apply the clock pulses at clock 2 terminal. Further, as the output of this NOT gate is high, this AND gate becomes active and we can apply the clock pulses at clock 1 terminal. Further, as the output of this inverter is 0, means the AND gates connected to parallel input pins A, B, C and D are inactive, means we cannot apply parallel input now. Further, as the output of this NOT gate is high, due to that these AND gates are active and this AND gate is connected to serial input pin. So if we apply some serial input here, it will appear as output QA as soon as we apply a clock at clock 1 terminal. For example, if we apply a serial input 1 here, then it will appear as 1 at the output of the AND gate. Due to this NOR gate, the output will become 0. Again, this is inverter. The output of the inverter is 1. Means S is 1, R is 0. Means the output QA becomes 1. Means whatever input we have applied, it appears at the output. Now this output QA is a serial input to the next RS flip-flop. So as soon as we apply the next clock pulse, this output will appear at QB. When we apply next clock pulse, that output is input to next RS flip-flop, so it will appear here, and after the fourth clock pulse, this output 1 will appear at QD. So this way, whenever mode control is connected to logic 0 and clock pulses are applied to clock 1 terminal, at that time this circuit works in serial in, serial out shift mode. So here again we connect mode control pin 6 to logic 1 by applying high voltage. Due to this, the output of the NOT gate becomes 0 and the output of this inverter becomes high. Due to this, the clock 2 AND gate is active and the AND gate corresponding to clock 1 is inactive. Further, the serial data cannot be applied from serial input, but we are ready to work in, parallel out mode. But you can see the modification in the circuit that only the pin D is free, whereas the output QD is connected as input to pin C. The output QC is connected as input to pin B and output QB is connected as input to pin A. Means whatever data we applied at input D, that will appear at QD, and this QD will serve as input to pin C when we apply the next clock pulse. So for example, if we apply high voltage at 1 at pin D, and as soon as we apply clock 2, this one will appear at QD. Now this one will behave as input to pin C. So whenever we apply a next clock pulse, it will appear at QC. This way, after applying 4 clock pulses, this one which was applied at pin D will shift in the left direction from QD to QA. This way, this circuit is said to work in serial mode left shift operation. So, thank you for watching.